The future of IVAS, development challenges and the next chapter of soldier augmentation. Few military programs in recent years have generated as much interest, controversy and potential as the U.S. Army's Integrated Visual Augmentation System, IVAS. Envisioned as the infantry equivalent of a fighter pilot's heads-up display, IVAS aims to revolutionize how soldiers perceive the battlefield. It promises to merge augmented reality, AR, artificial intelligence, AI, and network data into a single, soldier-worn platform that could transform ground combat. The program's future, however, has been reshaped by delays, redesigns, and now a major industry transition. In February 2025, Anduril Industries, the defense technology company founded by Palmer Luckey, assumed primary responsibility for IVAS's hardware and development from Microsoft, while Microsoft continues as the preferred cloud provider. Looking ahead, IVAS's future is not just about a piece of hardware, it is about whether the U.S. Army can successfully field a digitally augmented soldier and how this capability will evolve in the coming decade. This article examines the development trajectory of IVAS, its likely technological innovations, the challenges still ahead, and what its success could mean for the future of warfare. IVAS. Today, a brief status update. As of late 2025, the Army has reframed IVAS into a broader umbrella program known as Soldier Borne Mission Command, SBMC. This evolution reflects the Army's desire to correct course after years of technical issues with Microsoft's HoloLens-derived prototypes, broaden industry participation by involving both Anduril and Rivet, a startup competitor, ensure the system evolves into a scalable, deployable solution rather than a stalled prototype. Prototype headsets are expected by early 2026, with scaled deliveries targeted around 2027. The Army has signaled that IVAS SBMC is not just about night vision or situational awareness. It is about building a networked combat ecosystem in which every soldier is a sensor, every squad is a node, and data flows seamlessly across the force. Development pathways, where IVAS is headed. 1. Ergonomic redesigns and wearability. One of the program's biggest challenges has been comfort. Soldiers must wear gear for hours in heat, rain, and combat stress. Anduril is expected to introduce modular components, detachable displays, lightweight mounts, balance headset weight to avoid neck strain, improve field of view so overlays align naturally with human vision. The future IVAS will likely feel closer to a helmet-integrated visor than a bulky headset. 2. Smarter displays and adaptive AR. Current AR overlays can overwhelm users with too much information. Future development is focusing on adaptive displays that filter information based on the soldier's role or mission phase, use AI to highlight threats, movement, or anomalies automatically, transition smoothly between combat mode and training simulation mode. This evolution will make IVAS less like a cluttered video game HUD, and more like an intuitive extension of human senses. 3. Integration with AI and the Lattice platform. Anduril's Lattice system is central to IVAS's future. Lattice is designed to integrate data from drones, sensors, and vehicles into a unified picture. When paired with IVAS, this means soldiers could see real-time drone feeds directly in their visor. AI could tag potential enemies or hazards for the squad. Squad leaders could track every soldier's location and status without radios. This creates what the Army calls a digitally fused battlefield, where humans and machines operate as a team. 4. Extended power and durability. Battery life has been a recurring weakness. Future development aims for hot-swappable batteries for continuous use, energy-efficient displays and sensors, greater resistance to mud, dust, water, and shock. Anduril has emphasized ruggedization as a priority, recognizing that fragile electronics cannot survive in infantry combat. 5. Training and simulation. IVAS is also seen as a training revolution. Instead of relying on expensive mock battlefields, soldiers could rehearse missions in mixed reality, virtual enemies overlaid onto real terrain, after-action reviews showing exactly what each soldier saw, training scenarios uploaded instantly via cloud. This dual-use capability, combat tool and training device, could help justify the program's cost. The road to 2027 and beyond. Near term, 2025-2027, prototype competition. Anduril and Rivet deliver competing designs by early 2026. Field trials, selected units test headsets in realistic conditions. Scaled rollout. If successful, thousands of units could enter service by 2027. Midterm, 2027-2032, broad adoption across Army infantry brigades. integration with robotic combat vehicles and autonomous drones, expansion to special operations forces and possibly Marines, refinements in weight, optics, and AI features. Long-term, 2032 plus, IVAS evolves into a universal combat interface integrated into helmets, vehicles, and even aircraft. Potential fusion with biometric sensors, heart rate, fatigue monitoring. Development of augmented targeting aids for precision weapons. Collaboration with allied militaries for NATO interoperability. By the 2030s, IVAS may no longer be a headset program but a digital soldier ecosystem underpinning all ground operations. Challenges on the horizon: technical risks. Even with Anduril's expertise, the program faces unresolved risks. Can AR displays work equally well in desert glare, jungle humidity, and Arctic cold? Will AI reliably identify enemies without false positives that endanger civilians? Can networks handle massive data flows without latency? Cost and scaling. Each headset could cost tens of thousands of dollars. Scaling to hundreds of thousands of soldiers may prove prohibitive without reductions in unit price. Cybersecurity. As a networked system, IVAS is vulnerable to jamming, spoofing, or hacking. Future development must harden it against near-peer adversaries like China and Russia. Soldier trust. Perhaps the greatest challenge is human. Soldiers must trust IVAS as a reliable aid, not a burden. Any perception of distraction or unreliability could doom adoption. Ethical and strategic questions. Beyond technology, IVAS raises profound questions. Ethics of AR in combat. Does it risk gamifying war? Civilian use? Could similar systems migrate into policing or surveillance? Global competition? If the US hesitates, adversaries may leap ahead. These debates will shape not just IVAS but the entire trajectory of military AR. International context. Other militaries are also moving in this direction. China, developing AR helmets integrated with battlefield networks. Russia, experimenting with soldier-worn digital displays. NATO, allies, testing AR training aids and networked visors. IVAS SBMC may become the defining program in a global race to digitize infantry. Conclusion: toward the augmented soldier. The future of IVAS is no longer about whether the Army can field a better night vision goggle. It is about whether the Army can build a digitally augmented soldier who operates as part of a seamless human-machine ecosystem. Anduril's takeover signals new energy and a renewed chance to succeed. By 2027, the Army hopes to see the first large-scale deployment of a system that once seemed stuck in endless prototyping. If successful, IVAS will not just change how soldiers fight, it will change how armies think about warfare itself. The road is still long, the risks still high, but the vision remains compelling. A future where soldiers see not just with their own eyes but with the integrated vision of an entire force, powered by AI, Arkansas, and shared networks.